Hello, thank you for checking out Mr. Ware's videos. And today we're looking at growth and decay. The essential question is how do I write an equation from exponential growth or decay situation? So we're going to talk about the parts of each one here, and they extremely similar. They're exactly the same, except for the growth has a plus and the decay has a minus. So let's look at this. So the A represents the initial amount of whatever we're looking at. The R represents the rate expressed as a decimal. So whatever percentage or rate, you express it as a decimal. Okay? And X represents the time of how long it takes to grow or whatnot. Exponential growth occurs when a quantity exponentially increases over time by a fixed rate or percentage. Now let's look at decay. A again is the initial amount. R is the rate expressed as a decimal. And X again is time. But exponential decay occurs when quantity exponentially, you guessed it, decreases over time by a fixed rate or percent. So when you're reading a word problem and looking at it, you want to look for these things. You want to look for the initial amount, the rate expressed as a decimal, and whatever time it is. And it's important to know if it's increasing or decreasing. That way you know to use the plus or the minus or which formula to use. All right, let's continue. Okay, so in this first one, Anthony buys a fancy new electric car for $50,000. If the car depreciates at 10% per year, use the exponential function to find the value of the car in 7 years. So we got the initial amount, we got the rate, we know it depreciates, which means it goes down or decreases, and we got the time, 7 years. So we're just going to plug it into the formula. So we got the 50,000, okay, and since it depreciates, we're going to use y is equal to a times 1 minus r raised to the x. We're using minus because it decays. Now we need the initial amount, which is 50,000. All right, since it goes down, we're going to take the 10%, and we're going to convert it to a decimal. We convert it to a decimal, so we're going to move that decimal 2 places. That's going to make it 0.1, and then we're going to subtract it from 1. So that's going to make it 0.9. So we're going to take that 0.9 and plug it into our function. So we're going to have 50,000, which goes in for A. This 0.9, which is the 1 minus the R, that's 0.9 here, and we're going to raise it to X. That's the function. So we can figure out whatever years we want to. But we know that it's 7. So we're going to plug in 7. 50,000 times 0.9 raised to the 7th. So then you type that in your calculator. 50,000 times 0.9 raised to the 7th. And when you do, you get $23,914.85. So in 7 years, that $50,000 car should be worth this amount. All right, let's take a look at another one. All right, Lena's uncle invests $1,800 when she is born for a future 18th birthday present. The value increases by 9% each year. Use an exponential growth function to find the value of the investment on Linda's 18th birthday. All right, so Linda's uncle invests $18,000 when she was born. Okay, So it increases by 9%. So we're going to use the growth formula. Y is equal to A times 1 plus R raised to the X. All right, we're going to put the initial amount for A, which is going to be 1,800. Okay, it increases by 9%. So it goes up 9%. So you take the 9, you convert it to a decimal, moving it 2 places to the left. Okay, that's going to make it 0.09. We plug it in, we got 1 plus 0.09, so it goes up. So it's going to be 1.09. All right, so now we got our function y is equal to 1,800 times 1.09 raised to the x. So we know what years we want to put in, which is 18. So it's 1,800 times 1.09 raised to the 18th, which is 18. And that's going to be $8,490.82. It's a pretty good jump. Now, here's something you need to know about growth and decay. If you sit back and you see the function and it's less than 1, then it's a decay. But if you look at the function and it's a little bit more than 1 or anything above 1, it's going to be a growth. All right, let's look at a couple more examples. All right, in 2012, Emily started a new company with 18 employees. The number of employees increased by 25% per year after 2012. Using exponential function to determine the number of employees at the company in 2022. All right, so 18 employees and it increases by 25% per year. So since it increases, we're going to use the growth formula. Y is equal to A times 1 plus R raised to the X. All right. Now, the initial amount, and they said 2012, and they go into 2022. So the initial amount is 18. Okay. We're going to say 2012, and we're going to make that year 0. Okay. The next thing we're going to do is going to look at that 25%, and we're going to convert that into a decimal and add it with 1. So at 25%, since it goes up, we convert it to a decimal, which will be 0.25, and add it with 1, and you get 1.25. All right, now we're going to write the function. Y is equal to 18 times 1.25 raised to the x. All right, we want to know the employees in 2022. And if 2012 is year 0, 2022 will be year 10. So we're going to raise it to the 10. All right, and when you type that in the calculator, you get 168 employees. All right, let's look at number 4. All right, Nia buys a new iPhone for $13. Oh, sorry. Nia buys a new iPhone 13 for $1,000. The value of an iPhone depreciates at 41% every year. That seems high. Write a function in use in the to determine the value of the iPhone in 4 years. All right, so first you're going to write the formula, and since it depreciates, we're going to say decay. So we got the one with the minus. Next, we're going to write the initial amount, which is 1,000. Okay, we're going to take the rate, which is 41%, convert it to a decimal, and move the decimal two places. So you got 0.41, and you got 1 minus 0.41. And 1 minus 0.41 is going to be 0.59. So now we can write the function. It's going to be y is equal to 1,000 times 0.59 raised to the x. That's 1,000 times 0.59 raised to the 4, because we want to know in 4 years. Okay, then you type that in the calculator and get $121.17. In 4 years, that's what your iPhone that you spent $1,000 for is worth. Okay, so that's a quick little starter, notes and whatnot for doing exponential growth and decay. I'm gonna have a second part to this video. But for now, thank you for checking out Mr. Ware's videos. Have a nice day.